Word problems mess up a lot of students, but I'm going to cover the two main things that can help you with these. So the key thing is you always want to draw a picture, but the language is a little bit more difficult. They always use the word angle of elevation or angle of inclination. This is always starting with a horizontal line and the angle going up to the hypotenuse. So you can see from here, horizontal line, angle going up. Angle of depression is the opposite. We always start at the horizontal and it's looking downwards. So the hypotenuse is underneath the horizontal line and it's the angle between those two lines. Remember, it's always a horizontal line and it has to touch that. So let's take an example. We have some information. We have an airplane flying above Tom's house, 7 kilometers above. So we've got the airplane, Tom's house, and Tanvir's house. So we have the airplane. It's directly above Mike's house. So we're going to put in a line to show that the plane is above Mike's house. Once we've got that, we need to have an angle of depression. So I'm going to draw a line between the houses. And then I'm going to draw a line to finish the triangle between the plane and Tanvir's house. So at this point, we've got 3 sides of the triangle. And now we have to find where does the angle of depression go. Now, a quick review. The angle of depression is from the horizontal line going downwards to the hypotenuse. Go back to our picture. Up at the top, at the airplane, we have an angle going down, but there's no horizontal line. We do have a horizontal line down at Tanvir's house between the horizontal line and the hypotenuse. Where do we put the angle? So the key thing, and just to emphasize, angle of depression is actually the same thing as an angle of elevation. It's just a different triangle. If you do the triangle on bottom, the angle is at the bottom. If you do the triangle on the top, looking down, then we call it an angle of depression. But it doesn't matter which triangle you draw. So the key thing is, all that matters, find the horizontal line, doesn't matter which triangle you draw, and then add in your angle of depression. It's actually an angle of inclination, but it doesn't matter. Key thing I want to get across, whatever word they use, angle of elevation, depression, inclination, it always touches the horizontal line. If you can remember that rule, word problems get a lot easier. The second thing I want to go over is how to measure distances. Take this example. We've got Tarek. He's 18 meters away from the tree, and we want to measure the distance. So where do we draw the line? Now, to show you what not to do, imagine going to the top of the tree and trying to measure, with the tape measure, the distance. It just doesn't happen. It would be kind of dangerous to climb up there. So we don't measure to the top of an object. Another option is to measure from the bottom of the tree to the person. And in this case, notice, we don't usually measure through the air. What we actually want to measure is along the ground. And a nice kind of rule that works most of the time, if you can touch it, you can measure it. So in this case, we measure along the ground because we can touch it. So, key rule number 2, distance between objects, always measure the horizontal distance. Ideally, it's along the ground. Now, there are some exceptions. 2 of them. Every textbook will have a question on ladders or maybe even a kite. Keep in mind, notice that in both these examples, we're not measuring air through the hypotenuse. The ladder is the hypotenuse. You can touch it, you can measure it. So they could give you the measure along the ground, or they can give you the measure of the ladder or the length of the ladder. The kite one, this is when it's actually hard to measure along the ground because we don't know where to stop. There's no physical object directly underneath the kite. So most of the time what they will give you is the hypotenuse. They'll tell you the length of the string. That's what you put down. So keep in mind, if you can touch it, you can measure it. You can always measure the angle, and we always measure from the ground. So find the horizontal line. Hope that helps. Okay, so we're going to start with our first word problem. This one is a kite is flying in the air, and the string is 14 meters long. If the angle of inclination is 38 degrees, find the height of the kite. Okay, so now that we've read through the problem, we got to take out the most important parts. So, a string. We need to draw a kite. We have to have a string with it. And keep in mind, the kite isn't going to fly straight up in the air. It's going to get pulled at an angle. So let's start with a person. Draw the best person you can. And the kite is going to be somewhere over here, flying in the air. And it's pulling, the wind is pulling it, so it's going to look off in the distance. Now the key thing here is the string is 14 meters long. So if I draw on the ground, key thing is the string is up in the air. It's a hypotenuse. We want to fill that in. The next thing we're told is angle of inclination is 38 degrees. Remember, it always starts with the horizontal line going up. So in this case, the horizontal line is right here. It's the angle right there. And 38 degrees, fill it in. And the third thing, and what we're trying to find, is the height of the kite. So if I go to the kite, the height is straight down. We always want to make a 90-degree triangle. We need that to use sine, cosine, or tangent. So now that we've got the diagram, now it's just like the other problems. We just fill in, label the sides. Opposite is across. And we want to know the opposite. We want to know the height. And we have the hypotenuse. So right away we think sine fill in the numbers. Now the unknowns on top, which is what we want. So we get our number, round to 1 decimal place, and remember the units will be the same as this one. The height of the kite is the same units as the length of the string. So our next problem is Cynthia wants to find out how high the bird is in the tree. So we're told that she is 7.8 meters away from the tree and the angle of inclination is 62 degrees. So we've got Cynthia, we've got a tree. Let's draw a quick diagram. And we'll put the bird in the tree. So we're going to draw a triangle not to the tree itself, but to the bird. So we've got the ground, we've got the tree, and we've got Cynthia. So now we're told 7.8 meters away from the tree. So what we're going to do is we always measure things along the ground. We don't measure through the air. So 7.8 along the bottom. The angle of inclination, 62 degrees, always touches the horizontal line and the hypotenuse. Just always remember that rule. Always look for the horizontal line. We've got the two numbers in. Now we can find out what we want. We want the height of the bird. So we drew the triangle to the bird in the tree. We want to find the height. So now we just have to do the math. Label the sides. And the only ratio with adjacent and opposite is tangent. So we're going to use the tangent ratio. The unknown's on top, which is a good thing. We're just going to multiply both sides by 7.8. And we get our answer. The units will be the same as the distance away from the tree, so meters and meters. She is, or the bird is, 14.7 meters high. Okay, so we've got another word problem. A woman is in a building looking out the window. She sees a mouse in the yard or in the field, and she's 27 meters above the ground. Tells us the angle of depression is 62 degrees. Calculate how far the mouse is from the building. The key thing here is we want to start with a little picture. And we're going to have a window where she's looking from. We've got a little mouse out in the field, and I'm going to draw the ground. We're going to assume that it's 90-degree angle with the ground and the building. So from here, she's looking out, and we form a triangle to the mouse. Now we have to put in the information. Now it tells us 27 meters. She is 27 meters above the ground. So the height of the person. Now the angle of depression is the one that messes people up. If you look at this picture closely, I have an angle of inclination. So on the ground, it's going up. There is no angle of depression. Most people draw their triangles along the ground. It makes more sense for people. The problem is most people put the angle up here because they know the depression has to be from the top. But the rule is angle of depression, angle of inclination always has to touch the horizontal line. If you drew your triangle on the top, then yes, the angle would go there. If you drew it on the bottom like I did, it has to go down by the mouse. Key thing is, they're the same angle. They're the same triangle. They're just twisted around. So the key thing here is find the horizontal line. Doesn't matter what triangle you use. Doesn't matter what word they use. Find the horizontal line. So 62 degrees, 27 meters. Now I can do the math. I don't care if it's a depression or inclination. Find the horizontal line. So for this particular problem, we've got the labeled sides. I have the opposite, and we want the distance the mouse is from the building. So what I'm going to do is I'm going to circle this one, and the only ratio with opposite and adjacent is tangent. So we're going to find this. The unknown is on bottom, which we don't like, so we're going to do the switch. And plug it into our calculator. Once we do that, we get 19.6 meters. Now the key thing with this, looking at the diagram, this looks like it should be more than 27. But we just drew a triangle. We didn't know how far it was. It may not fit the picture exactly, but take a look, make sure it makes sense, go from there.